But I set it up as there's like whites. Um, like right here is all the cases. There'd only be 4 cases because 50% of the time, or there has to be 50 white and 50 orange. And then it just depends on the order in which you grab those. And then I just set it up as like the probability of getting a white one and then getting a white one for the second one would equal my probability coming out. But then I calculated the probability of getting a white and then an orange and then an orange and then a white
Yeah.
and then orange and then an orange. So I didn't know if that's kind of the direction that you were wanting us to go, because I know in the chat you talked about there being you wanted to find the probability that equal to half. I
No,
don't know if
all I said was, well, first of all, I don't think that you're correct in assuming that the number of orange and white are the same necessarily.
okay, so maybe I'm not
That's
understanding
not
that.
that's not true. So
Okay.
necessarily true. In fact, the whole point of the problem is for you to figure out how many orange balls there are. So it's sort of dubious.
That's true.
It's sort of
Okay.
dubious to assume that there has to be 2 orange balls.
I got you.
All I
Okay.
said was that the probability of getting the same color is equal to, right? So like you're drawing 2 balls, correct?
Yeah.
Okay. So I said that the probability that you get the same color with both balls is the same as the probability of getting 2 different colors. Okay.
Okay.
So all that means is that, and by the way, those are opposite probabilities, correct? If I go in and draw 2 balls and I have the same color,
Mhm.
that's the opposite of me going in and grabbing 2 balls and having 2 different colors. Yeah.
Uh-huh. Yeah. And
Okay.
so that's where the 50% comes
So
from.
those two things add up to 1. And I'm telling you that they both have the same probability. Just because 2 probabilities add up to 1 doesn't mean that each one has to be 50%, right? Because
Yeah.
the whole I'm a man and I'm not a man thing or something, right? I mean, that doesn't have to be
Yep.
50% necessarily. But I'm
Okay.
telling you that in this case that those are 50%.
Okay.
So the information that I'm giving you is that, I don't know, let's just do the probability of getting the same color. Okay. So either that would mean that either they're both white or what?
Or they're both
Or they're
orange.
both orange. Yeah.
Yep. Yep.
So the probability, I've told you in the question, the probability of getting the same color is 1/2. Okay.
Okay.
And then what I said is that there's at least 2 orange balls, right? If X
Yeah,
is,
so it could be less than 2.
huh?
So it could be more than 2.
Yeah, so it could
So
be greater
that's
than
what.
2.
Oh, okay, I got you. Okay.
And now, okay. So that means that the answer is there's only 3 possible answers. If,
Okay, so that's when you said it could be 2, 3, or 4.
yeah,
Okay,
yeah.
that makes sense.
So there's only 3 possible answers, either 2 or 3 or 4. Now, one of those is easy to rule out, okay? Because if there were 4 orange balls,
Then
what
there'd be no.
probability of getting the same color?
It would be. Was it 0? Oh, getting the same color. It'd be 100%.
Be 1. Is that
Yeah.
equal to 1/2, Josh?
No.
No. So
Okay.
one of those gets ruled out pretty quickly.
Yep.
So then the only ones that you have to deal with,
It's 2 and 3.
the case of either 2 or 3 orange balls.
Okay.
And really you only need to deal with either the probability of getting the same color or the probability of getting different colors. Doesn't matter. You just know that either one of those is equal to 50%.
Uh huh.
And then what you do is you just work with, the case where there are 2 orange balls and you say, okay, well, what's the probability of getting the same color if there's 2 orange balls? Okay.
Okay.
And if that's not 50%, then it had better be 50% in the case
Any other one?
of having 3 orange balls. Does that make sense?
I
So
think so.
you just have to work through those 2 cases.
Okay.
There's
Okay.
some very I'm not trying to be extra
Yeah.
picky or anything. So it's just, whittling it down to those 2 cases
Okay.
and just saying, well, which of these gives me a 50% probability of having, the same color?
Gotcha. Okay. Okay. That helps. That clarifies a lot.
All right, cool. Yeah.
So then question 7. I understand that like P, the probability of A given B has to equal P of A. And like just thinking through it, I was like, saying, or B doesn't affect, or B does not affect the outcome of A. And so because of that, I said it's independent. But I guess I was trying to think through, how do I truly show that in like writing? Is the goal is to like calculate the probability of A and probability of B, and then manipulate that to show that it doesn't
What are the 3 things? I mean, there were 3 equivalent ways that you could get independence. What were the 3 equivalent ways?
let's see. The first one was P, probability of A given B equals P of A, probability of A. And then there was probability of B given A equals the probability of B.
Yeah.
And then the third one, I'd have to look up the third one, but
It's
I
just
remember.
that the probability of A and B, the
Mhm.
probability of A intersected with B would have to be equal to the product
Oh yeah, of A and B.
probability of A, probability of B. All
Mm-hmm.
of those are equivalent. If you have
Uh-huh.
one, you have them all.
Uh-huh.
If you don't have one of them, then you don't have any of them. Okay?
Okay.
So if one of those fails, they all fail. But if one of them is true, they're all true.
Okay.
And the recommendation I'm going to make in this case is
Just check each one.
with not the conditional probability version, but just compute the probability of A, compute the probability of B, and then compute the probability of A intersected with B, and then just compare the product of the probability A, probability of B, compare that with the probability of A intersected with B. If those are the same, what do you know?
Then that they're independent.
And if they're not the same,
Then it broke one of them and therefore
yeah,
dependent.
then they're not, right?
Okay.
Yeah, so independence is equivalent to any one of those forms.
Mm-hmm.
In this case, it's probably not the easiest to work with the formula for conditional probability. It's probably easiest to just work with probability of the intersection and checking that against the probability of A times the probability of B.
Okay. Okay. Well, thank you.
Does that make sense?
Yeah, I think so.
All right.
Yeah.
Okay.
Thanks,
Cool.
Dr. Emmett. Yeah.
Yep. See ya.
Bye.